Are you all able to see my screen?
It's popping up.
Okay.
So it's still loading. Okay, we can see it now.
Awesome. Good morning, everyone. Again, to begin with, Happy New Year. Hope you all had a nice break and are all pumped up for the new year. Thank you so much to the Cognizant Academy team, Janine, Elvis, and others. For providing this platform for us to get the mind share from Cognizant, and as well as it provides us a platform to evangelize the Pivotal's products. So thank you so much. And again, to recap, last year we have covered a range of topics. We did topics on Pivotal Application Service, Pivotal Container Service, what are some of the best practices in building microservices, how do you cross the value stream, best practices in running PCF on different cloud vendors such as GCP, Azure, AWS, and so on. We also covered topics on application transformation. We covered topic on comprehensive security, as well as how do you monitor Pivotal Cloud Foundry using Wavefront. So that's what we did this last year. And to kick off this new year, 2019, we're going to start with Pivotal's data products. So today's session, I will be covering an overview of Pivotal data products, as well as I have 5 different demos. Let's see on the time. I will be covering a lot of material. So the good thing with the webinars is that these are all recorded, so you can always watch them later. So having said that, let's get started. So one other thing, so I also have invited my manager, Claude Devahine. He has been with Pivotal since the beginning, so he knows everything about all of our products. So while I present, since all of your lines are muted, please use the chat window, as Elvis has said and Janine has said that before. He will be there. Claude will be answering the questions, and I will also give 5 minutes at the end to answer any questions that are not answered. So if you have watched all my previous videos, right, like I always talk about, I have said this many times, the mission statement at Pivotal is that we want to transform the way the world builds software. And if you look at it, the central to that mission is always being great at working with data, whether it is managing data or analyzing it or connecting insights with applications. We help our clients choose the right architecture plus the right algorithms to power that digital transformation. So if you look at it, right, like the industry trends, these are some of the companies that are really harnessing the power of building software. And these are the ones that are disrupting traditional business and creating tremendous value. If you drill into these companies, you will see that what is driving them, right? So data is what is fueling the software. And these disruptors, if you look at it, right, they use a lot of data, whether it is Uber with hundreds of thousands of trip events each day, or Netflix with 400+ billion viewing related events per day, or if you look at Airbnb, which has like 5 billion training data points for price tip feature. So you can see that these companies, are dealing with data on a totally different scale than traditional enterprises. The way the data that tends to surface in their applications is quite interesting. There are different ways to use data, but one really great way to think about it is that it surfaces in their applications, as a feature. So if you look at Netflix, right, or Uber or Airbnb, so over at Netflix, over 75% of what people watch comes from the recommendations that they give. And that is true in my own household. Pretty much whatever I watch is based on what the Netflix says I will like it as part of my recommendation, right? So that's how they are using it. So how do these companies, these great software companies accomplish this? At Pivotal, let me get my pointer. At Pivotal, we see 5 key enablers that all these great software companies leverage. that are defining a new modern approach to data and analytics. At the foundation is this open source database innovation. The days of expensive proprietary databases is over. And if you look at it, all of the innovation enabling extreme scalability, performance, they are coming not from proprietary vendors, but if you look at it, they are coming from the open source communities. And then they also, the second enabler, right? Like if you look at it, parallel processing. This is essential for you to be able to operate at a cloud scale. And then the third enabler would be data science and machine learning. So those are some key ways that software companies are doing this. And then if you look at it, the fourth enabler is microservices. Rather than building monolithic applications, great software companies, they use a data microservices architecture to build, whether it is lightweight applications that can easily take advantage of this new data-driven services and insights as they become as they become available, right? So that's our fourth enabler, and finally, again, cloud-native continuous delivery. So these are if you look at it, I mean, these are the 5 key enablers. As you think about these enablers, right, ask yourself, I mean, these following questions. So if you, from your enterprise, right, can you consume a wide range of data sources and protocols? Are you able to modify the data pipelines and add processing steps as frequently as you can? Are you able to ask lots of questions of your data? Are you able to update algorithms and models daily? And are you able to build a cloud-native microservices architecture? And are you able to release new features in minutes, multiple times of a day? Because, I mean, if the answer is no, if you look at it, right, like total customers, our clients are able to answer yes to each one of these questions. So if your answer was no to any of the questions that I asked before, it is more than likely that your architecture looks like this. You must be dealing with siloed, kind of a siloed and aging database systems. Like you have a relational database here, relational data warehouse, a Hadoop clusters, you have a different messaging services. I mean, so it's a spaghetti of different products, and most of the time the IT budgets get strained by this expensive proprietary data management systems. And if you look at it, right, there is little to no structure in place to support continuous software delivery. And then from an analytics point of view, right, so they depend on this slow-moving batch-oriented data integration. So there is a better way to do this, and that's where Pivotal data products come in. So Pivotal data products provide you a truly kind of a modern cloud-native data architecture, one that simplifies your infrastructure and data architecture, but at the same time provides you with the power, speed, and agility you need to develop software, not in months or weeks, but in days or hours, right? So if I have to talk about, right, so the Total data products, I mean, we have some of the key products in that data suite is this Greenplum. This is the Total Greenplum database, is the world's first open source multi-cloud data platform, which is built for advanced analytics. Then we have this Pivotal Gemfire, which is a distributed in-memory data grid, which is used for highly available transactional systems. If your requirements are subsequent latency requirements, Gemfire is the product of choice. And then Greenplum also supports Apache MADlib. So Apache MADlib, it is an open source library for scalable in-database analytical methods. There are more than 60 graph, statistical, and machine learning functions that are supported through MADlib. And then there is this product called Apache Hawk, which is a Total HDB Hadoop database, which is a Hadoop native SQL query engine. So Hawk reads and writes data to Hadoop file system natively. So with that, having said that, I would like to go deeper into each one of these products. So let's first go to the Greenplum database. So to give you kind of a background around the Pivotal Greenplum, it was founded in September 2003, almost 16 years ago, by Scott Yara. He's our Senior Vice President of Products at Pivotal. So Greenplum was acquired by EMC in July of 2010, and it became part of the Pivotal in 2012 after it was spun out of EMC and VMware. So Greenplum is a so if I have to talk about the architecture of Greenplum database, right? So Greenplum is a massively parallel processing database. In Greenplum database, the data is divided into shards or many of the segments. What happens is that they run a single host, so we call it as a segment server, and these segment hosts are nothing but small Linux servers. So these could be the commodity COTS kind of a off-the-shelf hardware that you can get. So each of these hosts has its own CPU, disk, and memory. So in a production environment, right, the minimum number of segment servers you have is 4, but we have customers, I mean, with well over 100 segment servers. So how does the architecture work? So let's say you want to, so I have a SQL query. So what happens is that you directly never access the segment server directly. What you do is you speak to the master server. This is a Postgres instance running, and it has a metadata about the Greenplum database instance. All of your user data stays on the disks in the segment server, but the metadata lives on the disks on the master. Okay, so what happens is that let's say you have a SQL query. What happens is master parses that query, and then it develops a work plan, and then hands that off to the segment server. When it is finished, it returns the result. And then there is also this standby master. Again, I mean, as the name says, right? So if for whatever reason master fails, then standby takes over the master role. So there is another component here in the diagram. So there is this private interconnect network, so that the master and the segment servers, they are all on that super fast interconnect network. So essentially, I mean, this is the architecture of a Greenplum database. And where do you run it, right? So Pivotal Greenplum, you can run it. It's infrastructure agnostic, so you can run it on bare metal. You can run it on private cloud, whether it is on vSphere or OpenStack, or you can run it on public cloud, whether it is Amazon AWS or Azure or GCP. So we also support, so if you have a Pivotal Cloud Foundry, you can actually subscribe to the service through the Cloud Foundry marketplace. And on Pivotal Container Service, you can actually, Greenplum can be run on Kubernetes as well. It's in beta on PKS. It's in beta right now. It will be generally available soon. So that's Greenplum. That's where you can run it. And then I would like to talk about Apache MADlib, right? So that's your Greenplum database. So what happens? I was talking about the best practices, right? Like you don't want to silo your database as well as analytics. So what MADlib does is it provides you this open source library so that you can actually do the analytics, advanced data analytics in the database itself. So MADlib, what MADlib does is it actually provides, there are more than like 60 different graph, statistical, and machine learning functions that are supported. So if you look at it from a statistics and as well as from a data science perspective, right? Like it does support supervised learning, whether it is neural networks, regression models, linear regression, logistic regressions, the tree methods, decision tree, random forest, unsupervised learning, PMML support is there. In terms of statistics, it does descriptive statistics, inferential statistics, and so on. It also does time series analysis and so on. So when I do the demo, right, so what I will do, I have different data sets. I will show you a data set where we do descriptive statistics, inferential statistics. I will show you where we use the PMML for machine learning. I will show you linear regression, and then I will show you the decision tree. So that kind of gives you an idea. Right now, I'm only talking, but I will show you in the demo how it is done. Okay, so the advantage of MADlib is that you don't need to move data to a separate analytics environment. So all of this can be done in the database itself. So having said that, that kind of shortens the life cycle of your data science, right, from development to deployment. Next up, in terms of another great advantage is that, like, for text analytics, right, we have something called a GP text. So this is based on the Apache Solr cloud. So GP text, what it does is it supports both semi-structured as well as unstructured data searches. So Apache Solr is a popular open source search engine server for your enterprises. So that's Apache Solr, and then PostGIS, right? So whenever you have, let's say, like latitude, longitude, or like where you have like spatial data, for that use cases, we have something called PostGIS. What it does is, if you are manipulating polygons and geolocation kind of use cases, you can use PostGIS. And then, so there are like a lot of people, most of the statisticians as well as data scientists, even though you can do a lot of SQL analysis, data analysis using SQL, but they are quite familiar with statistical software such as R as well as SAS, SAS. So SAS is R is an open source version, and then SAS you have to purchase it. Okay, so I will actually do some demo on both SAS and R. And then finally, right, so another popular language that is out there is Python. And so Pivotal, so through Greenplum, we provide a syntax, and then there are packages and libraries that can be used for machine learning. So we support all of these other languages as well. So with that, having said that, let me go ahead and start a demo. So for someone who has not, so if you are like after this webinar, you want to try it out, right? So the best way to get started is that, like, if you search Google Greenplum and Sandbox, so you can go to this, it will take you to this page, network.pivotal.io, where we do give you a OBA file. So it's a Sandbox OBA. So that's what I'm doing here. So I used VirtualBox. So just import that OBA file, and then you will have a running Greenplum database on your laptop. Or if you rather prefer running it on AWS, there is an image up there for AWS as well. So that's a good way to get started. Once you have downloaded that, there are quite a few. So if I go here, right? So there are like quite a few tutorials out there with some data sets. So how do you create users? How do you create the database? How do you create the tables and so on? So to save time, I have actually already done that. So what I have done for the use case, I have this FAA data set. So this is a Federal Aviation Administration. So in this data set, right, so I have, let's say, if I look at window, right, so in this data set, I have different airlines in the airports in the United States. It has a list of all those airports, and then I also have different airline IDs and the time difference, like if there is how long, like if there is what is the delay in minutes and so on and so forth. So this is the data set that I have. So the first thing that I have to do is, I mean, this is in a CSV file, right? So Now, if I want to import this CSV files into my data, into my Greenplum database, the way I do that is, again, so if I go to my demo notes, let's see, so demo command. So here, so there are four different ways for you to import a data set. So one is you can use the SQL insert statements, or I could use, in this case, what I'm doing is that I'm using this copy command. Pretty much give the CSV files to copy and create a table inside my database. Pretty much that, but I mean, this works great for small data sets such as this. But if, let's say, you have like terabytes or petabytes of data, there is a way to import that data set, that is through using GPF dist, and then there is another utility called GP load. Both those methods support parallel. I mean, if you want to load data, right, like parallel data loading, so you can actually put a petabyte of data in just few hours. So once the data has been loaded, right, now I can do kind of in-database analytics. And to do that, right, so first up, what I have to do is I have to load the MADlib package. And the way I do that is pretty straightforward. So there is this MADlib package that you download from network.pivotal.io. And then the instructions that I gave you earlier, that page actually tells you how to do this. So pretty much you install the package on the server and then install MADlib into the database itself. So now that gives me all of those 60 plus database analytical utility functions that I was talking about. So now that exists in your database. So to prove this, right, like to do the demo, so now that the data has been loaded, what I can do is I can use this web-based SQL client called Ziplin. So what this does is I can actually do run SQL queries right from the browser itself. So very simple. I mean, now, I mean, just like any other database, right? Like I have a SQL query, I'm trying to find a count. Let's say I want to do a simple query such as I want to find the average delay, standard deviation, and the number of flights that are originating from Chicago O'Hare. ORD is Chicago O'Hare or Atlanta, right? So it's a very simple SQL query. But then, I mean, that's for if you want to find that. But if you want to do some advanced statistics, right? So if I want to do in statistics, there is something called one-way ANOVA. One-way ANOVA is that is analysis of variance. So if you want to determine, like, analysis of variance is nothing but if you want to determine if there is any statistically significant difference between the means of two different independent groups. So in this case, I'm trying to find out if the average delay in minutes between US Airways and Delta. So I can use this MADlib one-way ANOVA, and then as you can see the results, right? In statistics, there is something called F statistics and then the p-value. So as you can see, my F statistics is very low, so it's only 4.27, and the p-value is only 0.03. That's less than 0.05. If my alpha is 0.05, you can, I mean, just looking at this SQL query, you can say that, like, there is strong evidence that the null hypothesis. So you, so what you do is you reject the null hypothesis, and then if I do the same query, right, one-way ANOVA on, if I want to find out if there is any difference between Chicago O'Hare flights originating between Chicago O'Hare and Atlanta, if there is significant difference between the average time delay between these two airports, the statistical analysis tells me that my F statistics is really high, 774, and a p-value of 6.3. So, I mean, if you are a frequent traveler, you know that, right? Like, just off the hand, that I mean, Chicago is pretty bad when compared to Atlanta. And now, I mean, with this data set, now you can confirm that, like, with statistical analysis, with statistical data, you can say that yes, there is a significant difference. So that's some kind of one way of doing data analysis. So again, I mean, I didn't have to go outside, right? So I'm doing all of this in the database itself through MADlib. So that's a SAS. That's actually using Ziplin to query the database. But most of the statisticians and data scientists out there, what they do is they actually they just not they won't just use they are much more familiar not just with SQL, but they use SAS and R. So as I said earlier, right, SAS is a commercial product out there. So they are much more familiar with this product, as well as R is an open source product. So what Pivotal does is we provide this Pivotal SAS data science. We provide this macros so that you could actually use the same tool that the data scientists, the statisticians, they can actually use the same tool for them to continue working, right? So the way I do that is, again, I mean, so that's where my database server is running. That's on my IP on my laptop. That's the port number. That's the database tutorial database. That's the schema. That's the username and password. So now, if I want to talk about linear regression, like I can do all kinds of regression analysis that I was talking about before. So let's say if I want to do some kind of a linear regression, right? So to prove this, right, like what I have done, I picked up a data set from Kaggle. So if you are not familiar, if you are someone like if you are trying to figure out just learning this Greenplum, MADlib, and if you want to try some data sets, Kaggle is a good place to start. I mean, they do have lots of data sets, and then they do have lots of competitions. So, for example, right, like some of the competitions are free, and some are like you can actually make some serious money. So, let's say, for example, Zillow, right? Zillow had a competition where they are asking for like if you can actually improve their algorithm that predicts the home value, right? So this competition ended a year ago, and then the prize money for that like was $1.2 million. Even like Homeland Security, right? Like what they have done, they actually had a competition, passenger screening algorithm challenge, improve the accuracy of the Department of Homeland Security's threat recognition algorithms. I mean, so all these competitions, what they do is, I mean, they give the data set and then they ask you to improve upon the algorithms that they already have. So for the demo, what I have done is I actually used a competition called House Price Advanced Regression Techniques. And when I submitted, did the analysis, I actually scored 3,700, and the top score was 4,548. So I'm in the top 82%, but again, I mean, if I have to talk about this data set, right? So now they actually, so this is one test where I could actually get the data set. So I could just go to data, download the data set. So the data set itself, what they are asking for in the data set, right? So if I look at the data set, so what they did was they gave us so in Iowa, all of the sales price of all of the houses in that location, in that area, and so they gave initially a training set. So with the training set, what they did, they gave a sales price of the houses, and then there are like 78 different explanatory variables here. So when you sell a house, I mean, what are all the stuff that, so which zone it is, what is the square footage, what is the shape, whether there is a garage or not. So all of this data set that they gave, and then they asked us to create an algorithm that would actually predict the sales price. So just to show you the capabilities of how you can do this with Greenplum, right? So what I have done, actually I have, so if you look at my submissions, right? So I tried different algorithms. I tried stepwise selection, backward forward. So these are all statistical methods, regression methods that you can actually do. So there is lateral regression, there is a forward selection, backward selection, stepwise selection. And the stepwise selection is the one that actually performed better for me. So that was my submission, and that's how I got it. But if I have to show it in SAS, right? So if I actually show you this, so this is my code. So what I have done is I did some initial cleanup, loaded the data, and then did some log transformation. and then I did a stepwise selection. I did lots of other regression methods, and then stepwise was the one that performed better for me. And if you look at the results, right, like it is a linear regression, right? Like, I mean, a very good data set where like all of them are falling into this nice linear fashion. And if you look at, there are not many outliers here. My adjusted R square was pretty good. 0.88, it should be closer to 1, so this is pretty good. If you look at the normalization of the data, it was pretty good. All of the data points are in the residual plot. They are all in a pretty good fashion, right? So all of that, I mean, all this to say that again, all you have to do is pretty good. Like Pivotal provides you these macros, so you can continue to use SAS for advanced data analytics. So that is SAS, and a lot of people, if you look at the statisticians, right, they use R. R again is another programming language for that statisticians and data scientists use. Advanced data analytics, and Pivotal provides you this package called, and you all it's pretty straightforward. Install packages and search for Pivotal R. So I have already done that, so I installed that package. So if I want to know more about it, right? So if I click on that vignette for Pivotal R, it will open up a PDF and tells you that Pivotal R is an R package that provides a front end to PostgreSQL and all Postgres-like databases. So again, I mean, you could do all kinds of data analytics with the R as well. And the way you connect is very similar to SAS. I mean, you just give you the database connection details, and to show how R works, right? So I have a data set here. So let's say this is a HR data from your company, right? So you want to find out what are the factors that leave some people to leave the company, and why do they leave? What are the factors that influence a person's decision to leave the company? And if that's my data, and if I want to find out, I can do all this analysis within R. I just have to load that data into my database, and then so if I have to do, right, so what I did, I actually already so if I can do this correlation matrix, as you can see on the right. This gives me a heat map. This says that the total working years, the job level, years in current role, monthly income, and age are the factors that are contributing more to my attrition. But then I could also use a decision tree model that I talked about, the MADlib package. So what I can do is I can actually run that. So if I do that, right, so if I run this command, so based on the decision tree model, right, so based on that model, I'm saying that people with lower income, they are leaving, and people who have been working overtime, they have been leaving quite a bit. And then based on the job role, salespeople are leaving quite a bit as well. So, I mean, you could do all that kind of data analysis, advanced data analysis, right in the database using some of these tools. So Pivotal, R, SAS, all of these are some ways to do that. So pretty much that. So in terms of demo, let me see if there are any questions in the chat window.
I haven't seen any questions come in, Tej.
Okay, great. So yeah, please keep asking questions in the chat window. Claude is there to help out, and then I will also stop at the end. So again, I mean, let's go back to the presentation, right? So I talked about Greenplum, I talked about Gemfire. So let's look at some so similar, right? Like I have a query such as this, right? So you want to find out. This is a pretty complex query, right? So you want to find out people working at Pivotal. They know each other directly, and their names sound like Peter or Pawan. And who has withdrawn amount greater than $200 within 24 hours at an ATM less than 2 kilometers from reference latitude and longitude. So that's a pretty complex query. And if you have the data in your database, right? I mean, it's a simple query. So it's a query that you can run that finds what exactly you're asking for. So I can use Greenplum and Apache MADlib search. So here, that's what I'm doing here. I can use that, or I could use this Greenplum's time functions. For latitude and longitude, I told you that we have something called PostGIS. I could use that. And then GP text, as I said earlier, so it's for text analytics that you can do. And then there is this Greenplum fuzzy strings match soundex to actually search for that whose name sounds like Peter or Pawan, right? So pretty advanced stuff that you can actually do with the database, with all these functions that are inside the database itself. So to wrap up Greenplum, right? So Greenplum, as you can see, it's not just a database. It is a very powerful, massively parallel processing database where you can do some advanced data analytics, right? So you could do that. So with that, let's jump to Gemfire. I still have, I think, another 10 minutes. So let's go look at Gemfire. So again, a Gemfire, a bit of history of Gemfire, right? Gemfire was part of VMware's vFabric. So when Pivotal was spun out of EMC and VMware, Gemfire became part of this Pivotal's big data products. What are the use cases for Gemfire? You could use it for highly available transactional systems where you have like sub-second latency requirements. You could use in large-scale ticketing or financial trading applications. You can use it in IoT. You can do some real-time insights using live data. You can use it for self-learning, so smart systems. Or you could use it where you need continuous data flow or streaming applications, right? So that's where some of the key features of Gemfire, where it shines. To talk about the architecture of Gemfire itself, Gemfire is a key value object store. So what that means is that like you can actually store Java, C++, C#, and JSON objects, and you can actually scale your Gemfire cluster horizontally by adding additional nodes. It is a cluster-based system, so it can run it on commodity hardware or you can run it on cloud. Essentially, I mean, it's a in-memory data management system. So what happens when I say in-memory, right? So obviously that means that it is 10x to 100x faster than your traditional database management system. Some success stories of Gemfire is that at IRS, they use both Gemfire and Greenplum. So what they do is, starting from January till April, right? Like it's a tax filing season, and IRS uses these products to detect fraud. So while they process the returns, right? So they use it for fraud detection. They use both Gemfire, Greenplum, MADlib, and they use some complex SAS algorithms. The SAS that I was showing you before, they use some complex SAS algorithms to identify fraud. So that's IRS, and if I have to talk about usage by the numbers, State Farm has 23,000 application instances. GE has 17 billion records in memory, and China Railways, right? 3 terabytes of operational data in memory that they do, and they have like 4.6 million transactions a day, or 40,000 transactions per second. Pretty impressive, right? So both Indian Railways and China Railways, they both use Gemfire. So think about the scale, right? So 1/3 of human population use these 2 railways for their transportation needs. And it is powered by Gemfire, so pretty impressive. So that's the success stories, and then I would like to briefly talk about so Gemfire after it was spun out, after it became part of Pivotal. As you know, all of Pivotal products are open source. So in 2015, what Pivotal has done is they contributed the Gemfire code base to the Apache Foundation, and that's when Apache Geode was born. So this is the open source version of Gemfire. Okay, so Gemfire, Pivotal Gemfire is still the commercial product from Pivotal, and the open source version of it is Geode. Okay, and then we also have a product called Pivotal Cloud Cache. So this is used for microservices in Cloud Foundry. Again, it's based on Apache Geode. So for your microservices caching, Pivotal Cloud Cache is the product that you can use. Okay. Having said that, right? So let's quickly jump into another product that that enables you. That one is Spring Cloud Data Flow. So what is Spring Cloud Data Flow, right? So we talked about all these data products that so far. So Spring Cloud Data Flow is a toolkit if you are building a data pipeline, right? So that's when you use Spring Cloud Data Flow. So it provides you a complete toolkit for building data integration as well as real-time data processing pipelines. So to do this, right, like I think it's better that I quickly show you a kind of a demo. So to get started, Cloud Data Flow, it's pretty easy. Go to cloud.spring.io. You can actually on your local server, or you can run it on Cloud Foundry or on Kubernetes. Pretty straightforward instructions. So what I have done to do the demo, I actually have installed it on PWS. So that's where I have. So that's data flow server. So for this Spring Cloud Data Flow to run, you need for your stream and task data pipelines, you need a MQ server. So in this case, I'm using RabbitMQ, but then you can also configure Apache Kafka for that purpose. And for metadata, I have a MySQL database, and for caching purposes, I have Redis. So my Spring Cloud Data Flow is using all these three services. What we do is Spring Cloud. If you go to get started, right? Like if you just want to get started, we do provide app starters. So depending on the version of Spring Boot that you're using, there is a URL that you can use. So in this case, this one, RabbitMQ plus Maven. So all I have to do was go here to my applications and add an application and give the URL. So what it does is it downloads all those out-of-the-box apps. So so what this is doing is when you're creating a data pipeline, right? So let's say I want to, my source is a HTTP source, and then let's say I want to do some kind of a transformation. So there is a processor for transformation, and then once after I have transformed my data and I want to persist that to, let's say, whether it is a JDBC, if I want to persist this to a database, I can do that, or if I want to persist this to a log, I can easily do that as well. So to demo this, right, so let's go ahead and create a new stream. So let's create a data pipeline. So I already created some here, but I think let's do this one more time. So let's say I want to do a HTTP. HTTP is my source, so it's pretty straightforward, drag and drop. HTTP is my source. I want to do some kind of a transformation. So I just drag each one of those. And then I want to persist this, my sink is a log file. All I have to do is, again, drag and drop. And whatever the HTTP source that is, my payload, I want to convert that into uppercase. So that's how I define that, and then persist this to log and create a stream and then deploy it. So what it does is it will go ahead into Cloud Foundry. If you look at it, right? So what it does is it creates, spins up different containers, and then it actually, so to test it out, right, whether it is running or not, let's look at our runtime. So let's do a HTTP, right? So let me get the URL for this and get a postman. Let's do a post. So that's my URL. I want to do a post raw. Let's send good morning. So this is my source. I'm sending a data, good morning Cognizant, right? Like if I say, so I have a lowercase and uppercase, and all I'm telling it to do is, so if I click on send, so the 202 accepted, right? So now what it does is the data pipeline. Next is it will go ahead and what it does is it does the transformation. If I look for it, right? So good morning, Cognizant. So what it does is it actually did the transformation, converted it into a uppercase letter, and then outputted that to a log file. So pretty easy stuff. I also did something called Twitter analysis. So what I have done is all of my from my Twitter data, right? So if I want to see the some kind of, so I'm using TensorFlow for that. TensorFlow is a for all your machine learning stuff, right? Like I think there are like lots of open source software libraries for machine learning. So I'm using TensorFlow to do a sensitive analysis. So again, Twitter sentiment analysis is done by this person, Daniel Grattarola. What it does is it uses this convolutional neural network to perform sentiment classification on the tweets. Again, a lot of people do contribute to the TensorFlow, so I'm just using that. So if I want to look at these logs, right? So if I go to the logs, so as you can see, this is all coming from my Twitter feed. As tweets are coming in, so it's classifying them whether that tweet is a positive or a negative one. So pretty impressive stuff that you can actually do. So you can actually automate your data science pipelines as well using Spring Cloud Data Flow. So to wrap it up, right? Like I think I have only 7 minutes left. So as I said, I actually showed you Twitter sentiment analysis. I can actually do once I have all those tweets that are coming in, I can do some kind of advanced data analytics on those. So this kind of shows you that like if I do a pie chart, right? Like most of the time, most of the feeds that I'm getting out of my Twitter feed, they are positive, right? So you could do that. And then there are like machine learning algorithms and processors that are out there. This is one example. This is an object detection model, again TensorFlow model. So if your input is an image, right? So again, the TensorFlow, what it does is it does the processing, and then it tells you that these are the persons. This is a kite. This is water. So it will do that classification. So really cool stuff that you can actually do using Spring Cloud Data Flow. So another use case so to tie everything together, right? So one person I would always recommend to follow in Pivotal, right? Like there are, I personally follow Josh Long and Christian Zolov. These are Spring engineers at Pivotal. I mean, great repositories out there that you can actually try and learn stuff. So he has done this. So if you want to try it out, right, this real-time fraud detection with data microservices, this is a use case that uses all of the products, right? So here we are using Greenplum database. We are using Spring Cloud Data Flow for enriching. So what it does is it has a filter that does this machine learning evaluation. And then what it does is it does filtering, and then for fraud detection, it puts that into a Gemfire cluster for subsequent latency, right? So to run this, what I have done, so let's say I have a banking application, right? So you want to find out if there is any fraud that is happening. You can actually use this, right? So to demo this, right, like what I have done, I actually let's run this point of sale emulator. So if I run this within few seconds, what it will do is I already ran a machine learning script that actually does the training and testing. So let's go ahead and look at it. If I refresh this, right, it takes few seconds, but great use case, fraud detection, so that uses all of the so as you can see now, like it's popping up, like all those greens are like there is no fraud happening. But the moment there is a fraud happens, that green will turn into red, and then it will show up in the suspect transactions. So you just have to watch it like for a couple of minutes, and then it will show up. But right now it's not showing up. But take my word for it, it will work. Okay, so great place to try this demo if you want to. So that's Sprinkler data flow. Another use case, I think I just have one slide left. The reference architecture. So one other use case is for IoT. So for IoT stuff, right? Like this is a reference architecture. So let's say you have your real-time data coming from the sensors, right? So what they can do, they can be processed using Sprinkler data flow that I showed you, and then it can go to your in-memory data grid, and then go to your in-memory data grid, that is Gemfire, and then you can do the machine learning evaluations, right? Using models evaluated here, and then the transactions that are persisted into the Greenplum database. So that's a reference architecture that you can use for IoT. So to wrap it up, final slide. So as you have seen, I mean, Pivotal data products, I mean, great depth and depth to the level of stuff that you can do with the product. So the Greenplum, Gemfire, Sprinkler data flow, Cloud Cache, and then the data science team that we have in-house. So look at it, right? So Pivotal is your partner as your enterprise. If you look at it, it takes this incredibly important digital transformation, and as you look at it, these products help you in that transformation. It will help you in modernizing your data platforms. It will improve the performance and scalability, and lower your overall total cost of ownership, right? So great set of products out there. Pretty much that's it for the presentation itself. Any questions in the chat window that needs to be answered?
Claude, I see you were responding to some questions. Do you want to unmute your line and just voice any questions which you think we need to address? Claude, I'm not sure if you heard me.
Sorry? Claude, any questions that we needed to answer?
Yeah, there was Swami was asking for the GitHub URL, but I was responding to someone, so I kind of missed what you were showing, Tej.
Okay. So what I will do, everyone, I will share the GitHub links that I was talking about as part of, like, I will share the slide deck that I was showing, as well as the people I was talking about that you should follow. All of this data, I will share it in the, I will share it with Janine, and Janine will share it to you.
Okay, great. There was a similar question about the slides.
Okay.
Just new question that came in was with regard to monitoring.
Okay.
And yes, we are sharing the deck. Tej did say we will share the deck.
Okay. Sure.
So I'm not sure what the question really means, because it says whatever apps are deployed, do we have any link which highlights on monitoring? It just really depends where you're deploying it. If it's in Spring Cloud Data Flow, then the developer has access to all of their logs, and then you can hook that up to things like Splunk or Papertrail. So yes, there are many ways, but it really depends what we're talking about. If it's within the Spring Cloud Data Flow, there are multiple ways for you to capture what comes out of your apps. Absolutely.
Great. Awesome. So we are almost on time as well. So again, I mean, it was a great last year. So, so at the beginning of the session, I talked about the stuff that we covered in 2018 and 2019, right? So we did this total Greenplum. So this was today's session. And for next month, we are going to talk about Kafka overview and integration with PKS. So again, I mean, these webinars are, we can change that. Like if there is interest for any particular topic, just let me know. As always, my email address is, I'm just typing in. Please reach out to me. Any questions, I'm your PA to help out. as well as Claude. Claude is my manager. He handles the entire the PA team for the Alliance. That's all I have. Janine, you have anything to